So let's say you wanted to work out what 1 divided by root 2 was. So 1 over root 2. What is that as a decimal? Now, let's say we know what root 2 is. Okay, so we've worked that out to a reasonable degree of accuracy. We've got 1.4142135662, etc. Root 2 is an irrational number. So as a decimal, it just keeps on going forever and ever and ever and ever, and it doesn't repeat itself. So the problem with that is that dividing by this value is very difficult to do by hand. Okay, so 1 divided by root 2, I mean, you could cut it off at certain points, truncate it, as we would say, okay, and you could get ever closer and closer and closer, but it makes the job very challenging indeed to get an accurate figure. So 1 over root 2 is difficult to find. So what we want to figure out is there an easier way of working out what 1 divided by root 2 is? And that is by going through a process of rationalizing the denominator. Because the problem is that we have an irrational number in the denominator. We're dividing by an irrational number. That's what's causing the problem. So if I can remove the square root from the denominator, so I'm not dividing by it, and instead I'm multiplying by it, because multiplication is in general easier, then that makes my life easier. So that's the intention here. So what we're going to do is we're going to manipulate this fraction into an alternative form. And to do that, we multiply by 1. Now that seems like a very strange thing to do. Why would we bother multiplying by 1? Well, the thing is, it doesn't have to be written as 1, because I know that I could write it as 2 over 2, for example. Okay, I could write the fraction as 2 over 2, that is still 1. Okay, there's nothing wrong with that. I could write it as 20 over 20 if I wanted to. But the whole point is to make sure that I get rid of the square root in the denominator. So I'm not going to choose 20 over 20. And I'm not going to choose 2 over 2, but I will choose root 2 over root 2. Now, the reason why I'm going to pick that is because I'm going to get, when I multiply these two fractions together, the numerators multiply together to make 1 times root 2, and the denominator I've got root 2 times root 2, which I know is 2. So I have 1 times root 2, and then I've got root 2 times root 2. So what I'm showing here is that 1 over root 2 is the same as root 2 over 2. Or you can write that as 1/2 of root 2. So actually 1 over root 2 is the same as dividing this by 2, or multiplying it by 0.5, whichever you prefer. And I can do that very easily, to whatever degree of accuracy you want, whereas the division was much harder. So this is the idea behind rationalizing the denominator. What's happening is very much what this expression says. I am rationalizing the denominator, so I'm making the denominator rational. And 2, being a rational number, makes this much easier to figure out what it actually is as a decimal. So that's what we mean by rationalizing the denominator. And we could go through another example very easily here. So let's say I had something like 4 over root 3. 4 divided by root 3, difficult to find. So I'm going to multiply it by 1, but I'm going to choose the 1 to be root 3 over root 3, because I know that when I multiply those denominators together, I will rationalize the denominator. So I have 4 lots of root 3, 4 root 3. Root 3 times root 3 is 3. So I actually have 4 root 3 over 3, or 4/3 root 3. So if you know what root 3 is, then you could just multiply it by 4/3, and you will get what 4 divided by root 3 is.